Steelway Building Systems has always taken the lead in technology, both in the office and in production. Going to Autodesk Advance Steel was a fundamental change in our process, where we would look at one building model from the front-end architectural end right through design, drafting, and obviously into our production facility.
Steelway Building Systems is one of the leading manufacturers for steel building systems here in Canada.
We tackle a wide range of different types of steel building systems, from industrial to commercial to institutional and everything in between.
We fabricate the entire product at our facility. We do the hot rolled, 3-plate, cold form steel, and cladding profiles as well.
Historically, the process of detailing a building was a tedious one.
We would spend a lot of time laying out a building in 2D and creating all the shop drawings manually, which took a lot of time.
Our process would be the checker would redraw the entire building to check the manually generated shop drawings.
It could be hundreds, could be thousands of drawings that add up, in time.
Now that we have Advanced Steel, we simply import the building model and view it in a BIM environment.
The linking was key for us, was being able to have a company that could take what we're currently doing in our current 2D design software and enhance it into a BIM model. We saw a lot of excellent features with Advanced Steel right out of the box. Certainly the hot rolled sections. They had a number of connection libraries for the light gauge sections. They had decking profile, and certainly the tapered beam object.
The custom connection tool helps us build a library of our own connections that we can use on basically all our designs. With Advanced Steel, the drawings are correct if the model is correct.
The checking time has been greatly reduced, and there's confidence in the output that once we spend a little time at the front end in the building model, shop drawing generation comes from the model, so it's correct. The outputs from the XML, it comes from the model, so it's correct. We now read that output from the model into our current shipping list, which we've used for years. We could use a lot of the output that we saw with Advanced Steel to link to the plant floor.
For the 3-plate line, the plasma cutter would receive the DXFs directly from the model and nest them on the appropriate sheet and cut them to size. Near the plasma is the bar line, where certain size bars are sheared and then fit up to connect with the webs that are cut from the plasma. All of that is then fed through a pull-through welder and welded together. In the hot rolled area, the 5-set machine receives the NC files directly, and that contains data on the different holes, the length, the cuts. It then moves along through the shop blaster to be painted and welded later on. In the cold form section, NC files again are sent directly to the machine, again with all the data that is required. So holes on the webs, the flanges, the cut lengths, and everything that's needed. So it's a greatly simplified process when the information is received automatically from the office.
We're one of the first North American companies to have robotic weld cell for a tapered beam object. Take some custom programming to be able to do that. With Advanced Steel, we see a lot of advantages to being able to complete our links on the shop floor and enhance them.
We were concerned about the learning curve between AutoCAD LT and Advanced Steel, but a lot of the commands were the same. And even just navigating through Advanced Steel was, I found, fairly easy. You're just putting beams and columns where they need to be and putting connections in. No need to worry about, oh, did I miss, counting a bolt or a beam or a column, because Advanced Steel puts that quantity in for you. And there's no worry about, dimensions being wrong. It's correct because it's straight from the model.
Our dream system would be for an architect to have our system, our components in, say, their rivet model. We get that model. We can then finalize the member sizes, do the final design, send that model back to the architect to approve it. Where everything can be done in a BIM workflow, we find some huge advantages of better communication up front, getting more details sorted out front, not changing something when it's literally in the shop floor. We feel it's very important in our market to be the industry leader in technology, and we feel that a product like Autodesk Advance Steel will be able to give us that technological edge that we need in a very competitive marketplace.